So let's wait for the streaming, then we start the class. So let's start with the one short revision of the modern physics. So first of all, actually, before going to start the modern physics, so there are basically 4 parts in the modern physics. So which parts we are going to study if we are talking about in modern physics beta. So in modern physics, our first part is the photoelectric effect. Okay, and at least 1 to 2 questions in every set that will ask from this section that photoelectric effect. So this is very important topic for us. Second one is the atomic physics. Third one is the nuclear physics. And the last one is the, we can say, a X-ray. Okay. So there are the subtopics in the modern physics where question is generally asked. 1 to 2 questions asked every year from the photoelectric, and I think at least one question asked from the atomic physics also. So we have to prepare in very well manner these 2 topics. Okay. So first of all, we start with the photoelectric effect. So what is the photoelectric effect? Actually, photoelectric effect, as we know that whenever if we consider a metal surface, suppose this is a metal surface. When photon is incident on this metal surface, what is the photon? That is the particle behavior. We can say particle behavior of the energy will be considered, that is the photon, and one photon having the energy hc upon lambda. Okay. So we know that if this is the metal surface, metal having 3 electrons, and if this energy is enough to eject the electron from this surface, then this type of phenomena is known as the photoelectric effect, and that is the observed by the Einstein. So we can say that what is the minimum amount of energy required to eject the electron? That minimum energy beta, that minimum amount of energy is known as work function. Okay. So if we say total energy that incident on this surface is E, that energy of photon, this energy goes into 2 parts. One is the work function, that is the minimum energy, and another is the kinetic energy of electron emitted. Generally, we consider the kinetic energy maximum kinetic energy, for which we can say that E is input energy and the K maximum the energy that electron will eject out from the given material. So first of all, the direct question is asked, what is the work function? That H into mu or Sc upon lambda. This mu naught is known as the threshold frequency. What beta? That is the threshold frequency. What is the meaning of threshold frequency? Because we can say this is the minimum frequency required to eject the electron. And if this is minimum, then lambda will become maximum. So this lambda naught is known as the threshold wavelength. This is known as the threshold wavelength. Okay. So in this formula, if we write down in this manner, that this can be written as H into mu equal to H mu naught, that is the threshold, into K maximum. Okay. So if we want to plot the graph between the K maximum and incident frequency, what is the graph beta? Can you draw the graph? If in y-axis, K maximum, that can be written as, here we can say this is nothing but H mu minus H mu naught. Y equal to mx plus c minor. So we can say that this is our graph. Okay. here in y-axis K maximum is taken, and in the x-axis that is the frequency. Okay, that is the incident frequency. So here there are basically two types of question is asked. What is the graph? That is the straight line, and what is the slope? If you want to find out slope in this graph, what is the slope beta? This tan theta is nothing but Planck constant. Okay, and what is stopping potential? Suppose if we consider a cathode ray experiment, so this experiment, suppose if we having two plate and if we connect this plate with a battery, okay, and if we incident a photon here, then electron will eject from here because positive terminal of battery is connected to this plate. So this is anode and this is the cathode. So what will happen beta? Because this having negative potential, so electron will repel in this direction. It means if some electrons having the maximum kinetic energy, in spite of maximum kinetic energy, they will repel in this direction. So we can say by the battery, work done by battery, we can always retain as that E into delta V. And this potential that given by battery that act like as a barrier for the kinetic energy of electron. So that maximum kinetic energy that is compensated by this work done by battery, and this potential is known as the stopping potential. So sometimes in the graph is also plotted with the stopping potential versus incident frequency. So we have to prepare for this also. What is the nature of the graph? I hope this is clear. And one more thing, beta. In whole modern physics, if we want to find out the incident energy of photon, that is the hc upon lambda. So generally energy is given in the electron volt. So we have to very much clear about if we put the value of h into c, then this value we have to learn that 400 electron volt, and lambda we have to put here angstrom. Okay, so by using this formula, whatever wavelength is given, we generally put in angstrom, and the product of H into C in the electron volt is the 12,400 electron volt. So we can solve the problem easy. Okay, so that is very, very helpful most of the time in such type of questions. Okay, so what is the stopping potential that we can see here? That stopping potential here we can also write down here. If you want to write down to H mu upon E, and that can be written as H mu naught upon E. Okay, so in this case, what is the slope? In this case, if you want to find out the value of slope, if the graph is between stopping potential and the frequency, so in this case, slope is nothing but H upon E. So that direct question will ask in this concept, we have to mentally prepare. One more thing, beta, such type of question is asked. What happened with intensity if we increase the suppose if this is our metal surface, okay, and here photon is incident. If we increase the intensity of photon, then what will happen with photocurrent? What will happen with photocurrent? What is the photocurrent, beta? Suppose if photon incident on this surface, so electron will ejected from this surface, so this will become positive charge. If we want to make this plate neutral, then what we have to do? We have to earthing this plate. If we have to connect with earth this plate, then we can say that the electron will move from earth so that the plate will neutralize. Okay, so direction of current. So electron will move in this direction. So this is the direction of current. So we can say that there is a current flow in a metal so that the plate will become neutral, beta, and such type of current we can say the photocurrent. Okay, so this is a very, very important graph. The graph is also given in the NCERT. If we increase the intensity of photon, then what will happen with the current? Intensity is number of photon per second. What is the meaning of intensity? That number of photon, if we increase number of photon per second, if number of photon per second increases, then we can say that rate at which electron emit from the surface, that will also increases. So we can say current will also increases. So the graph is nothing but graph is beta straight line. We have to keep in mind, in this case graph is straight line. The second type of question that is generally asked, what is the second category of the question? What will happen if we increase the temperature? If we increase the temperature, so there is no effect on photocurrent. We have to keep in mind, no effect in photocurrent. Okay. So I hope this is clear. No effect in photocurrent. One graph you also know that what is the relationship between the stopping potential and the incident frequency. The another term that we have to keep in mind, what is the momentum of the photon? So that is the h upon lambda. Okay, the relation we already discussed here. The next term, that what is the radiation force or radiation pressure? First of all, we have to understand what is the radiation force and radiation pressure. Suppose this is the surface. If we consider this surface and photon incident perpendicular to this surface, okay. So we know from mechanics that whatever force applied by the material, that is the rate change of momentum. Okay. So if we consider that, suppose if this is a surface and here photon is incident on this surface, then what is the force beta? That rate change of momentum. And what is the change of momentum with one photon? That h upon lambda into number of photon. What is the number of photon beta? Number of photon is nothing but beta, that we can say here that if we want to write down P upon HC upon lambda, and that lambda will cancel out. So this will equal to, we can say that if we want to write down what is the number of photon per second. So first of all, we want to discuss number of photon per second. So let us understand this concept. Suppose if we want to say that the total energy incident on the surface, that always written that the number of photon into hc upon lambda, where hc upon lambda, that is energy associated with one photon, n is the number of photon. And if we want to convert this term into power, then we have to divide over t. So this will become power. So if we want to find out number of photon per second, that n by t, this value can be written as p lambda upon hc. This is the value of number of photon per second. So here, if we want to find out the force, so how we can write down the force? That momentum of one photon, that h upon lambda into number of photon per second, p lambda upon hc. So here we can say that lambda and lambda is the cancel out, and this result will be equal to p upon c. This result is equal to nothing but p upon c. What is the p here, beta? P is nothing but power. P is nothing but power. And one important relation we know that intensity is nothing but power upon area. So power can be written as I into A. If we put this value here, this will equal to IA upon C. IA upon C. So here we know that this force can be written as IA upon C, where I is intensity, A is the perpendicular area, and C is the speed of light. Okay. What is the pressure? Force upon area. If we divide area here, that is I by C. That is a very, very important formula. Here, there is A and R is given. What is the A? That is the absorptivity. If this surface absorb all the photon, then reflectivity is 0. And we know the relation that A plus R is always equal to 1. So here we can say that if A equal to all the photons that absorbed by the surface, then the force is IA upon C and pressure is I by C. If all the photon that revert back, emitted by this surface, reflected back, then what will happen, beta? Then this case, absorptivity equal to 0, reflectivity equal to 1, and this formula will become F equal to 2IA upon C. We know that it is basic formula by change in momentum. Change in momentum concept, and we can generalize this formula in this way. Suppose for in general case, if there is some reflectivity is given, then what is the formula? IA upon C 1 plus R. What is the important formula? This If reflectivity is 0, then put R equal to 0 here. Then we will get which formula? That is the first one. If absorbability equal to 0, then we will get second formula. So this is important formula of F and P. I hope this is clear, because whenever radiation force, radiation pressure is asked, you can easily solve by using this. Sometimes if the photon is incident at some angle with vertical, then we have to take a component, and we know that in this case, the photon is incident with some angle, then what is the component? Beta, say this angle is theta, so we can say this will become cos theta. And again for the pressure we have to take again that perpendicular area, so one cos theta is also come. So in this case this formula will become this. Okay, I hope this is clear. This is not too much important regarding JEE main, but some and how we have to keep in mind such type of variation is occur. Okay, the next one is the dual nature. What is the dual nature? That is described by the de Broglie, and the de Broglie wavelength, de Broglie hypothesis is nothing but beta that lambda equal to h upon mb. Okay, because there is a duality, particle is also behaving like as a wave, so we can also given such type of relation, a wave associated with a every particle. Okay, and we already know that beta this energy, kinetic energy, is also written as nothing but under root 2m into charge into potential difference. Okay, so this is the formula just similar to magnetic field, where we learn about what is the radius of the charged particle, that h upon mb, h upon p, h upon under root 2mk, and h upon under root 2m qb, where v is the potential difference. V is the potential difference. If we see unsolved paper of the last 4 years beta, this is the very important and the concentrated point for the examiner. From here the question is asked. Which type of question is asked? Suppose a proton and alpha particle is given. Okay, and they are accelerated with same potential difference. If this is given, they are accelerated with same potential difference, then find the ratio of their de Broglie wavelength, that ratio of that lambda proton upon lambda alpha. How we can solve? We have to just catch which one parameter is going to be constant here. If in the problem it is same that same potential difference, then we have to going to use last one formula. Okay, and we can see the relation here. Lambda is that is inversely proportional to mass into charge. So how we can write down? We can directly write down that mass of alpha, charge of alpha, mass of proton into charge of proton, by using this relation, because potential difference is constant. So how we can write down beta? That mass of alpha divided over mass of proton into charge of alpha divided over charge of proton. And we already know that beta alpha is nothing but helium nucleus. So helium nucleus, that 2He4. So what is the mass here? That mass of alpha is written as 4 times of m. Charge of alpha is written as 2 times of E. Mass of proton, that is nothing but, if we say that is the m, and the charge of proton, that we can say that is E. If we put the value, we will get answer. In such type of question, if there are 3 particles are given, listen here, if there are 3 particles given, one is the proton, one is the deuteron, and one is the tritron, and the 3 particles are projected in a particular same velocity, then find the ratio of their de Broglie wavelength. That lambda proton, lambda deuteron, and lambda tritron. How we can solve this? Okay, so we have to see that which parameter is going to be constant here. Speed is given constant, then we have to use first formula. If momentum, then second. If kinetic energy, then third. I hope this is clear, and I hope you can solve very easy manner in such type of problem by see the relationship, if there is direct relation or inverse relation. I hope this is clear. Okay, so let's move to the next section. The next section is beta question. Okay, so in the same concept, the question is asked in 2022. 2022 and 2020. Both the years the question is asked. I hope this question you can solve easily. Here we have to find out the ratio of the relation of the wavelength of electron, helium and proton. So we can say that here the same kinetic energy is given. So can you tell me answer? You have 10 seconds. Can you tell me answer which answer is going to be correct here? Which answer is going to be correct here? Come on, beta. Which answer is going to be correct here? Can you reply yes or no? How you can solve? How you can solve? I hope this is clear. Oh. So you can know that sir, this can be written as lambda is nothing but under root 2mk. Okay. Here kinetic energy is constant, so lambda is proportional to under root mass. We know that beta mass of helium nucleus that is greater than mass of proton and mass of electron. So this is the inverse relation. So here we can say that the lambda electron is greater than a lambda proton is greater than lambda helium nucleus. Okay. So in this manner you can solve given problem. Again the question is, that is again a good problem because in this question they want to mix the concept of the KTG. Okay. The nitrogen molecules are given and the particular problem it is saying that the RMS velocity at 400 Kelvin and assume that RMS velocity 400 Kelvin पे we have to find out and de Broglie wavelength पूछा है बेटा. तो कैसे हम सोचेंगे? We can say that कि sir we know that कि lambda equal to हमारे पास तो यही फार्मूला है h upon mv h upon p and h upon under root 2mk kinetic energy. So how we can write down the kinetic energy beta? And we know that the kinetic energy we already know in our previous kinetic theory of gases how we can write down the kinetic energy for a given molecules. That nothing but 3 by 2 kT. I hope this is clear for everyone. So if we put this kinetic energy here, this lambda will become h upon under root 3m h upon under root. This will become 2 and 2 cancel out here, that 3m kT. Okay. What is the m here beta? M is the mass of molecule. M is the not molecular weight, that is the mass of molecules. Here we can easily find out if we put the value here at 6.6 3 into 10 raised to power minus 34 divide over under root 3 into mass that is given beta 4.64. The mass is given, we have to put the mass and the Boltzmann constant is also given. What is the Boltzmann constant is given? Okay, and what is the temperature? That 400 Kelvin. So in this manner we can proceed and solve the problem. We have to do some calculation also. So we have to clear which type of question is generally asked and what procedure we have to follow. Okay. The next question is again asked on the de Broglie wavelength. So take your time, solve the problem. You have 1 minute to solve this problem, beta. What is given here? Velocity is given, electric field is given, lambda naught is the initial de Broglie wavelength. In this problem, we have to find out what is the de Broglie wavelength at the time t. So how we have to think in such type of problem? If this is the x-axis, this is the y-axis, and velocity is given beta xy plane, and the electric field that is applied is, we can say, in the minus z-axis. Okay. So what is the initial velocity? If you want to write down the initial velocity, that is nothing but v naught I cap, v naught j cap. So what is the magnitude of initial velocity? That we can say that beta that v naught under root 2. Okay. What is the velocity after time t? Because this electric field is constant here. If we see the data, electric field is constant. If electric field is constant, so we can say that the force experienced by the electron is also constant. So we can say the force is also constant. And what is the force beta? Force is nothing but beta, that charge of electron into electric field, that is constant. If force is constant, then acceleration is constant. If acceleration is constant, then we can use the equation of motion. And what is the acceleration here, beta? That E upon mass of electron. So after time t, what is the velocity? We can write down v equal to u equal plus at. So what is the velocity, beta? What is the u? V naught I cap, V naught j cap, and put the value of acceleration. The acceleration that is given here, we can say in the electric field is given in the minus k direction. So we can say that the force that experienced by electron in the plus k direction. I hope this is clear. So this value we can write down here. Nothing but E naught divided over m into t, and the direction that is given, beta, k cap. So what is the magnitude of velocity, beta? If you want to find out the magnitude, this is nothing but under root v naught square plus v naught square plus a square, e naught square, and m square. I hope this is clear for everyone. And this will equal to, beta, 2v naught square plus e square, E naught square divided over m square. This is the final velocity of particle at time t. It is asked about if initial de Broglie wavelength of electron. So what is the de Broglie wavelength initial, beta? That h upon mb. So h upon what is the mass? If we consider the mass m, what is the initial velocity? That v naught root 2. So this will become v naught root 2. What is the final wavelength, beta? What is the final wavelength? If this wavelength is given at lambda naught, so we can say the final wavelength h upon mass into this velocity. If we put this velocity here, so this will equal to 2v naught square plus e square, e naught square divided over m square. So beta, if we want to form equation lambda final in the terms of lambda initial, then what we can do here, beta? We can say, sir, if we take v naught root 2 common here, then what will happen, beta? Inside, what will happen? So this will equal to, if we take common here, that 1 plus a square, e naught square, and divide over 2mv square, v naught square. I hope this is clear. And this value is nothing but, beta, this value will equal to lambda naught. Which one is the correct answer, beta? I hope this is clear to everyone. Option C is the right one. So such type of question, that mixed concept is applied, that the concept of the de Broglie wavelength and the kinematics. Okay. So which type of question that can be formed? Electric field is given, magnetic field is given. Then we have to think about the net force. If we net force, we can to think about. Then we have thought about the acceleration. If we get acceleration is constant, then we can apply the concept of the motions equations. Okay, because our fundamental role is find out the de Broglie wavelength, and de Broglie wavelength is nothing but h upon mb. And for h upon mb, we have to calculate the velocity at time t. I hope this is clear. So mentally prepare such type of questions. Again, this question is asked. I hope this question is easily can you solve, beta. What is given here? Relation of the potential difference is given. Then which type of formula we are going to use? Anybody, beta? That lambda equal to h upon under root 2m charge into potential difference. I hope this is clear. And it is given that charge q is accelerated once 50 voltage, and another charge particle, that is the charge q, and mass 4m is given, that accelerated is the 2500 voltage. So what is the ratio of lambda a upon lambda b? We can directly say, sir, if charge is same, h is same, 2 is constant. So how we can write down here, beta? So we can write down here that is nothing but, beta, under root that mass of b upon mass of a, and potential difference of b upon potential difference of a. Just put the value and you will get answer. Just put the value and you will get answer. What is the mass of b is given, that is the 4m, that is m. What is the potential difference of the b, that is given at the 2500, and this will become 50. You can solve and you will get answer. One more thing, beta, that is the Davison-Germer experiment. In the Davison-Germer experiment, it is the find the wavelength of the electron. And what is that wavelength, beta? Keep in mind that Davison Germer experiment. Okay, what will happen? That is the important point. Sometimes it will ask that lambda can be solved for the electron. So H upon, we can say H upon 2m charge of electron into potential difference. Actually, if we put the mass of electron, charge of electron, then which value we will get, we have to keep in mind beta. 12.26 divide over under root potential difference. Okay beta, and this value we will get the value of lambda in the angstrom, and we have to put potential difference in both here. So we have to remember this formula. This is only valid for the electron. Okay. So if we remember 12.26 divide over under root voltage, we will get the value of the wavelength. Okay. Direct question asked in the previous year. If we vary the voltage, then what is the ratio of the lambda? Okay. I hope this is clear. In this question, it is asked as intensity of incident radiation is increased. How we can increase the intensity of incident radiation beta? We know that the intensity of incident radiation is only increased if we change the frequency of incident photon. And by this graph, we can say this is the graph between potential, stopping potential versus 1 upon lambda. And 1 upon lambda is nothing but we can say this nature is similar to frequency. So here straight line shift to right, no. If straight line shift to right, then we can't change. So what is the nature? How we can comment such type of graphical question? Just write down the equation beta that stopping potential can be written as HC upon lambda and here E and HC upon lambda not E. So by visualizing this equation, we can comment. Okay. So what is the answer here? Graph does not change. Okay. So graph does not change if we increase the incident radiation. So why graph is not changed? We have to understand this. Earlier I explained only current is increased. Okay. This is the next question. That is the homework problem for you guys. You can solve easily. What is the when the wavelength of the radiation falling on a metal surface is changed 500 nanometer to 200 nanometer, then the maximum energy of photoelectron becomes 3 times larger. So what we have to do here, beta? Such type of question. Firstly, we have to write down the Einstein equation for photoelectric effect, and we know that that can be written as in this manner: K maximum equal to nothing but that HC upon lambda minus S. Answer is given in the electron volt, and 80 to 90% chances in the modern physics the energy is given in the terms of electron volt. So directly convert into electron volt, and how we can convert it beta? That 1200 420. Yeah, 1200 400. Okay beta, 12,400. We have to remember this beta. तो 12,400. अब यहाँ लैम्डा क्या होना चाहिए बेटा? एंगस्ट्रॉन में होना चाहिए. बट यहाँ पे आप ध्यान से देखो कि जब ये एनर्जी हम यहाँ पे नैनोमीटर में दी है, तो ये वैल्यू क्या लिखनी पड़ेगी? तब लिखनी पड़ेगी 1240 अपॉन लैम्डा नैनोमीटर. आई होप दिस इज क्लियर. पुट दिस वैल्यू. सो के मैक्सिमम फर्स्ट केस में सपोज करो के है, ये वैल्यू कितनी होने वाली है बेटा? यहाँ से वी कैन से दैट सर दिस विल 1240 डिवाइड ओवर लैम्डा. इनिशियल केस में 500 नैनोमीटर, नो प्रॉब्लम. ओके. What is the SC upon lambda? This is nothing but beta, this is the work function, and it is fixed for a given material. So say this is the constant phi. In the second case, this will equal to 3K. What is this value? 1240 divide over what is the wavelength now? 200 nanometer, and this will become phi. They say this is the equation now, this is the equation 2, and we have to calculate the work function. So what we have to do? If we divide equation 2 to equation 1, what we will get beta? 3K upon K, this will equal to 3K upon K equal to, we can say here, this will nothing but if we cancel out this, so this will equal to beta 12.4, and 12.4 this can be written as 6.2 minus 5. So this will be written as 6.2 minus 5 divide over, if we divide here, so this will equal to it by 5 to the 10, and we can say that 2.4. Okay, 2.4. We can solve this minus 5. So if we cancel out here and if we solve for 5, you will get correct answer. So what is the approach, beta? We can take approximation if we see the options are not too close. If options are too close, then we have to solve exact value. So what is the concept we have to keep in mind? If the same material is given, then the work function is not going to be changed. And whatever equations is given, this is the fundamental equation by which you can solve any type of problem of the photoelectric effect. Okay, let's move for the atomic physics. In the atomic physics, beta, there are two fundamentals that we have to apply. That is explained by Bohr's. Okay, so that is also known as the Bohr's model. Okay, this is nothing but Bohr's model. And Bohr's model, what is happened, beta? Let me explain. In Bohr's model, that we consider that if this is the nucleus and if electron is revolving in a particular orbit, okay, then there are two fundamentals principle that here applied for getting such type of formula. One is the, if electron is revolving, then it must needed centripetal force that is provided by the electrostatics force. Okay, so one equation that we can write down here, if the charge of nucleus, that is the Z times A. So one is the centripetal force that can be written as K Q1 Q2 by R square. Okay, and if this radius is the nth orbit, we consider that is Rn square. And this centripetal force is always written as mv square upon R. That is the nth orbit. And the second is the beta concept of the angular momentum. For the nth orbit of electron, the angular momentum rate nh upon 2 pi is equal to particle angular momentum rate mv upon r. If we solve these two equations, because there is only two unknown, one is the nth orbit radius and another is the velocity in nth orbit. So if we solve Rn and for V1, we will get this type of value that Rn equal to n square upon z. Always keep in mind that our radius of nth orbit, that is proportional to number of orbit square divide over atomic number. Okay, where this is the constant and this is known as the Bohr's radius. In previous years, one question is asked, if this radius is depend upon the mass, which type of relation? It's having the mass of the electron. So if we remember only this formula, you can't able to get right answer. So that's why we have to remember such formula also. If we not remember such formula, but you know what is the relationship between the mass, where Rn is the inversely proportional to mass also. Okay, beta? So Rn is the inversely proportional to mass. But at the same time, if we see what is the velocity, that velocity that z upon n. So we can say that velocity of nth orbit is nothing but z upon n. And in the velocity equation, that is independent of mass. So velocity does not depend upon the mass, but radius depends upon the mass inversely. Okay, beta? What is the energy of nth orbit? The energy of nth orbit, आप ऐसे याद कर सकते हो बेटा, एनर्जी कहाँ से आएगी? वेलोसिटी के स्क्वायर से. तो वेलोसिटी का स्क्वायर करोगे तो क्या होगा? जेड स्क्वायर एन स्क्वायर. इसका मतलब यहाँ पे जेड स्क्वायर अपॉन एन स्क्वायर आएगा. आई होप दिस इज क्लियर. सो वी कैन से कि एनर्जी इज प्रोपोर्शनल टू जेड स्क्वायर अपॉन एन स्क्वायर. Sometimes different type of question is asked. Let's see. We know the radius. Yes, sir. That is proportional to n square upon z. We know the velocity. Yes, sir. That is the z upon n. We know the energy of nth orbit. That is also proportional to z square upon n square. How many types of question is asked? When electron is revolving, then current is also flow. If their time period is also happen, angular frequency is also happen, angular momentum is also happen. So which type of question is asked? What is the proportionality of the angular speed or angular velocity? What is the angular velocity, beta? V upon R. What is the proportionality of V? Z upon N. So Z upon N divide over N square upon Z. So what we will get here, beta? We will get here that Z square upon N cube. Z square upon N cube. We have to keep in mind. And we know that the time period is nothing but 2 pi upon omega. So what is the proportionality of time period? Just reciprocal of this N cube upon Z square. N cube upon Z square. I hope this is clear for everyone, beta. Okay. What is the ratio of the current, beta? The current in nth orbit. What is the current, beta? That charge upon time. Charge upon time. So we can say electron charge upon time, so that is also reciprocal of the time. So you will get also the same type of relation for the current also. I hope this is helpful. How such type of question is asked. And there is one fundamental we have to know that, beta, in the particular orbit, say this is the ground state n equal to 1, and this is also say that K cell. This is the K cell. If this is known as the n equal to 2, that we can say that is the L, that n equal to 3 here, and n equal to 4 here, n equal to 5 here. Okay. If electron is emitted from any cell to any other cell, then photon is emitted. Okay. So any other excited state, if electron get jump into n equal to 1, that is known as the ground state. So what will happen? Such type of series where electron is jump at ground state from higher order of the series, that is known as the beta Lyman series. That is Lyman series. I hope this is clear. Okay. And if electron will jump into n equal to 2 from the higher, that is known as the Balmer series. That is the Balmer. If electron jump from higher to n equal to 3, then this is known as the beta Paschen series. That is known as the Paschen series. And for n equal to 4, this is known as beta. This is known as bracket series, and last one is the Python series. So we have to remember this. Only Balmer series, whatever radiation occur here, that come into visible region. So Balmer series come into visible region. We have to keep in mind. Balmer series radiation come into visible region. Okay. Otherwise, if we talk about other, that is bracket, P, and Paschen, that come into infrared region. Okay. Lyman, that will come in the ultraviolet region. So we have to keep in mind. And one more thing we have to keep in mind, after putting this equation, that En equal to minus 13.6 Z square upon N square. If we put N equal to 1, 2, 3, 4 here, then we will get this value. If we remember this value, we can solve question easily better. Yes, Janos, we have to remember this. N equal to 1, this value equal to minus 13.6, and this gap is larger. If this gap is larger, so we can say this energy difference is greater. As we move upward direction, energy difference get decreases. It is the minus 3.4 Z square, 1.5 Z square, 0.85 and 0.54. So at infinity, the energy will become 0. So what is the energy difference if we want to write down? That is Hc upon lambda. And if we solve lambda here, beta, 1 upon lambda can be also written as beta Rz square, 1 upon N1 square minus 1 upon N2 square. So you have to keep in mind. The question is asked, that is the concept of the photon, number of photon concept. Okay, what is given here? The 2 milliwatt laser operates at a wavelength of the 500 nanometer, and the number of photon that will be emitted per second. So number of photon is asked here, beta. How we can think about the number of photon? As earlier we explained that, beta, suppose if in one photon that contains energy of Hc upon lambda, if you consider that there is n photon per unit time, that n by t can be written as Hc upon lambda. Because if we check the unit, this will become power. So this is the power. So what is the number of photon per unit second? That we can write down the P lambda upon Hc. Here power is given that 2 into 10 raised to power minus 3. Lambda is also given in the problem 500 nanometer. Put the value in the meter. H value is also given 6.6 into 10 raised to power minus 4 and 3 into 10 raised to power 8. So in this manner we can solve. We have to always think what is asked in the question and how we can remember the formula. Okay, this is again a good problem, beta. In this question, that use the concept of the electromagnetic wave also, and it is asked about the stopping potential. How we can think about the stopping potential, beta? What is the stopping potential? So if we want to find out the value of stopping potential, then we have to think this equation, that stopping potential is nothing but K maximum E into stopping potential. Okay. What is the K maximum, beta? Sir, we know from the Einstein equation K maximum is always written as that Hc upon lambda minus work function. Okay. So once we get K maximum, then we easily calculate stopping potential. That stopping potential is nothing but K maximum upon E. What is given here, beta? Here the equation of electric field is given, and always compare the equation equal to E naught cos kx minus omega t. So what is K value here, beta? That is wave number. What is the K? Wave number 2 pi upon 5 into 10 raised to power minus 7. And what is the wave number? Wave number is written as 2 pi upon lambda. Okay, sir. So if we want to calculate lambda here, what is lambda, beta? 2 pi upon k. Put the value of k here, that nothing but 2 pi divide over 5 into 10 raised to power minus 7. This is the value of lambda 5 into 10 raised to power minus 7 in meter. And we know that the final answer, this value is applicable in electron volt. Okay, so can we convert into angstrom? Yes, we can convert into angstrom, and this will become 5000 angstrom. I hope you can understand this. So what is the value of K maximum here, beta? We can say ki Hc, we can directly write down, beta, 12375 divide over 5000. Okay, this value will come electron volt. This is in angstrom. What is the phi is given? That is the 2 electron volts. So we can calculate K maximum here. And what is the K maximum here, beta? That this will become 12.375 minus 2. And if we divide over 5, what we will get here? This value is nothing but, beta, that 5 to 10, and we can say that this value 2.75 minus 2, that is the 0.75. This is the value of K maximum electron volt. Put the value here. This will equal to K maximum E into Vs equal to 0.7 electron volt. Electron cancel out, and Vs value is the 0.75. What is the approximate correct answer? That option B is the correct one. I hope this is clear. Again, the question is asked. In the concept of the number of photon. So here the plate area is given, radiation intensity is given. So can we calculate the number of photon easily? Okay, because we know the formula, beta. Here we can see that what is the number of photon per second. Okay, and this formula is nothing but Pc upon, that we can say in earlier slide we can say n Hc upon lambda upon t is nothing but that is the power. So we can say this will equal to number of photon per second P lambda upon Hc. What is the power, beta? Power is nothing but, beta, intensity into area. Okay, lambda divide over Hc. Here plate area is given, intensity is given, so we will get this value. And also it is given that the work function is also given. Phi is also given in the problem, that 5 electron volt. Energy of incident photon, that is given 10 electron volt. So here this value Sc upon lambda is direct given, that 10 electron volt. So here we can calculate the value of number of photon per second. If we get number of photon per second and it is gain only 10 percent of proton that produce photoelectrons. So again, we will find out the 10% of this, that 1 by 10. Okay. So if we solve this value, we can say that here the effective number of photon per second we will get. Okay. And once we will get this value, then what we have to find out, that maximum kinetic energy. This is the very easy. That K maximum is nothing but total energy, that hc upon lambda minus work function. Okay. So here the total energy of incident photon, that is given at the 10 electron volt, and 10 minus 2 we can also find out this value also. Okay. 10 minus 5, that is the 5 electron volt, and here we will get number of photon effectively. The next is the nuclear physics beta. This is the important formula, because the size of nucleus is proportional to the mass number, and size means volume. Volume means 4 by 3 pi r cube. So pi r cube is proportional to mass number. So r is proportional to a raised to power 1 by 3. So here we remember this formula. Such type of question is asked. Suppose if the mass number of aluminium is given and the mass number of some atom oxygen is given, and find out the radius ratio of their radius of nuclei. One is the what is the alpha decay. We know that here the proton number is decreased by 2, mass number is decreased by 4, and momentum is always conserved. Keep in mind, momentum is always conserved, mass is always conserved here. And when the mass is converted into energy, this value is known as the Q value. Okay, what is the Q value, beta? That mass of reactant minus mass of product into C square. And this value is generally written as 1 AMU. And 1 AMU is nothing but beta 1.66 into 10 raised to power minus 27 kg. So sometimes if we convert this value, that Q equal to MC square from Einstein equation beta, this value can be written as mega electron volt, that mass defect into AMU. Mass defect को AMU में put करो into 931.5 mega electron volt. So how we can calculate the beta mass defect? That mass of reactant minus mass of product. Okay. So what will happen in the case of beta minus decay? Beta minus decay, we can say decay of electron. So we just conserve the charge here, that is the Z, and we have -1 charge. This will become Z. Okay. And this type of particle, subatomic particle, is known as the antineutrino in the case of beta minus. But in the case of positron, neutrino will emit. Okay. So what will happen in the case of beta minus decay? So we can say that in the case of beta minus decay, so if there is, here we can say that one neutron will get converted into proton. Okay. So the next, sometimes when nuclei get unstable, it will break, disintegrate for the stability. Okay. So there is one term we have to also understand, that graph between the mass number and binding energy per nucleon. Binding energy per nucleon. And the graph is something like this. What is the graph described? For a particular mass number, the binding energy per nucleon is maximum. That shows the maximum stability, and that will occur for the iron. Okay, that will occur for the iron. So the region that near about iron, that is known as the stable region, and that is the mediocre nuclei. So we can say that when a heavier nuclei that want to disintegrate and make a stable configuration, that's why in the case of heavier nuclei, nuclear fission is occur. Nuclear fission is occur. At the same time, when we talking about the two lighter nuclei, they also want a stable configuration. So they will get combined to get stable configuration, that is known as the nuclear fusion. So nuclear fission and nuclear fusion, that will also explained by this graph. And what is the concept of the radioactivity? That is also based on the that number of nuclei after time t, that n equal to n naught e raised to power minus lambda t, where lambda is decay constant and t is the time, n naught is the number of nuclei present at t equal to 0. Half-life period we have to also derive from here. we know that at t equal to 0, number of nuclei is n naught, and if time equal to t half, then number of nuclei become n naught by 2. If we put this value, we will get this value of the half-life period. We have to also remember this value ln2 upon lambda. T average is nothing but t half upon 0.693. Generally, we can solve the problem by using this. So there are some questions are attached in the given slide. So we have to try the question, and the upcoming next 2 days, we will come back with the top 40 to 50 problems that is expected for the JEE Mains. So student will prepare for the given problems, and next 2 to 3 days we just do practice and practice. So take care and thank you so much for attending the class.